Okay. This is Cambridge IGCSE O levels. Paper number is 5070, chemistry paper discussion. The time target is 1 hour, and this is an alternative to practical paper. That means, in case if you don't have a practical in your school, if your school doesn't support a practicals, you will be awarded with this kind of a paper. Yeah, let's get into the discussion. A student investigates the rusting of nail. So as soon as you see this experiment, you should get into the mind that rusting can be caused by the presence of H2O and O2 gas. O2 gas. This can be present as a liquid as well as a gas. So okay. Here in apparatus A, both the H2O contact, the water contact, and atmospheric contact are there. So rusting will definitely take place. In experiment B, a stopper is used and the air is dry air, so no water. So the presence of H2O is not there. Only air contact is there. Next one, we use an oil layer as well as water. Here the specialty is water. We boil the water and we use. The reason for doing this is because when you boil the water, all the gases dissolved in the water will escape. So in this water there is no O2. Only pure water is there. And this oil layer is there to prevent O2 from the atmosphere dissolving in the water again. Okay. Name the apparatus A, apparatus X. So we can name it as boiling tube or test tube. The difference between boiling tube and test tube is the size. And boiling tube is suitable for high temperature. The reason for selecting boiling tube, especially because boiling tube is much wider than the test tube, so it's easy to put the nail and take it out. You can write test tube as well. They will be avoiding marks. They will be avoiding marks. State why a stopper is used in experiment B. We can simply write to avoid um, water vapor, water vapor getting in contact with the nail. Okay. State why water in this experiment is boiled before use to remove the O2 gas present in the water. That's easy. State why a oil layer is used in experiment C to prevent O2 gas in the atmosphere getting in contact with the nail. Okay, that's good. The experiments are left for 1 week. The reason for leaving it for 1 week is because rusting won't happen. If rusting is a very slow process. There are two factors that will accept. There are more than two factors, but according to the scope of the syllabus, there are mainly two factors that affect the rate of rusting. First one is acids. When metal comes in contact with acid, the rusting rate increases. Or else salt. When the metal comes in contact with salt, the rusting rate increases. Okay. Here, predict which of the experiment the nail will have rust. Obviously, experiment A. A. The explanation, explain your prediction, because in experiment A, the nail is in contact with both water and O2. Okay, that's it. Now let's go to the second question. Second question is a titration based question. As soon as you see this question, you should be able to figure it out, and it's also given in here, so you don't have to be that much keen on it. There are steps given. These steps must be you should read the steps properly. Uh, yeah, read the steps properly. But for the first few questions, they are just asking the volume change. For these things, you don't have to go through the question. I'll first do this thing, and let's dive deep into the question. So yeah, they're asking the pilot readings. Initially, reading of the titration 1 is 0, and final reading is 15.2. In titration 2, it starts on the 15.2 and ends with 30.2. So volume used is difference, final minus initial. So 15.2, here also 15, yeah, just 15. Okay. Remember, if they are giving two values, and if it is for a single titration value, most of the time they might ask an average value. Okay, so keep that in mind. Figure B shows the Biret reading for one of the titration with B. Okay, there is two solutions, one is A and the one is B. Okay, in B, there is a value already given. So titration, this is titration 4. The initial reading is 0.6 and final reading is 35.5. Yes. So if you take the change, it's 34.7 and 34.9. Yes, 34.9. Explain why student uses a white tile in this titration. Okay, now we have to read the question. A student uses two samples of aqueous ammonia, A and B, with 0.5 mole per decimeter cube of hydrochloric acid. So this is an acid base titration. Student does 4 titrations, 2 with A and 2 with B. Step 1, rinses with Biret with hydrochloric acid. Next one with using a pipette to conical flask. Then 5 drops of methyl orange to the conical flask. Places the conical flask on white tile, and they're adding few drops ends in solutions. They're adding methyl orange, right? They're adding methyl orange. Methyl orange is a color changing indicator. So the white tile is used. The reason for explain why the student uses white tile. So the explanation is to observe the color change easily. Okay. Next one. When it is a white tile, the reference is much closer, so you can see the color change. If it is a different color background, it's very difficult to observe the color change. Okay. Calculate the mean value of this much of hydrochloric and unit neutralized. Okay. Remember, in the Biret, they are using the hydrochloric acid, HCl, and in the bottom flask, they have the ammonia samples. Okay. Yeah. Calculate the mean volume of hydrochloric acid needed for the solution. Okay. Here it is 15.2 plus 15.0. If you find the average, 15.2 plus 15.0 divided by 2, it is 15.1. So average value for first one is 15.1 centimeter cube. So second one is, it's here. If you find the average, it is 34.8. It is 34.8. I hope I don't have to explain how to find the average. Next one. The equation shows for the reaction between hydrochloric acid and aqueous ammonia is shown. Using the mean volume of acid needed to neutralize of A in D to calculate the concentration of ammonia in A. Okay. To an appropriate number of significant figures. Okay. So in this reaction, the stoichiometry of acid to the base is 1:1. That is one of the important point to be found out. So whatever the question, if it is a chemical calculation based question, most of the time the calculation, almost 99% of the time, the question goes with finding moles. So first let's find the moles of HCl. Okay. To find the moles of an HCl, we need to multiply the concentration with volume. Concentration is already given 0.5 mole per decimeter cube. And the volume is given. This is not the volume, this is the volume of the base NH ammonia. So the volume is 15.1. We are taking the average. Okay, 15.1 decimeter cube. This to this cancel. 0.5 multiplied by 15.1. It should be around 7.55. 7.55 more. Okay, that's good. Next one. You can compare the stoichiometrically coefficients. N of HCl and N of ammonia is in 1:1 ratio. So there is an important thing we missed. Here this is given centimeter cube. We have to convert it to decimeter cube. So 10 to the power of minus 3 is required. So here it cancels. So 10 to the power of minus 3. Here the moles of HCl is 7.55. It is mole. 10 to the power of minus 3 mole. If this is then 7.55 10 to the power of minus 3, then the moles of ammonia used is also 7 point moles. The question is they're asking the concentration. So concentration can be found by moles divided by the volume. The volume is already given. So mole is 7.55 incident to the power of minus 3 moles. And the volume is 25 incident to the power of minus 3 decimeter cube. 10 to the power of minus 3, 10 to the power of minus 3 cancels. If you use a calculator, 7.55 divided by 25, you get 0.302 mole per decimeter cube. Okay. Now the F part. Calculation of ammonia gas measured at room temperature and pressure, RTP. RTP means room temperature and pressure. Dissolved in 25 centimeter cube of air. Okay. The volume of 1 mole of a gas of any gas is at RTP is 24 decimeter cube. Okay. The concept of molar volume is when 1 mole of a gas is there, it occupies 24 decimeter cube of volume at room temperature and pressure. Okay, but we have 7.55 10 to the power of minus 3 moles. So what is the volume we have? What is the volume of gas it occupies? The volume can be found by 24 multiplying by 7.55 10 to the power of minus 3. If you multiply, you should get an answer of 0.181 decimeter cube. You have to account for the powers as well, 10 to the power of minus 3. That thing also you have to consider. So the volume is 0.181 decimeter cube. Using your answer to D and F, calculate the volume of ammonia gas measured at RTP in B. Okay, so that is, you are repeating the same thing, but you can do it quickly now. So mole of HCl at second instance is concentration into volume. Concentration is still the same. And the volume here used is 35.8. 34.8, sorry, 34.8. So 10 to the power of minus 3 decimeter cube. This cancel. So it must be 17.4 into 10 to the power of minus 3. So 0.174. 0.0174 moles. So moles of HCl is equals to mole of NH3. So it is equal to 0.014 moles. So to find the volume, we have to multiply the moles with the molar volume, you get 0.417. So 176 decimeter cube. Okay, you can write the answer as 0.41 417. Yeah, that's enough. The student rinses the burette with 0.5 mole per decimeter cube of hydrochloric acid immediately before it is filled. Explain why the student should not rinse the bottle with distilled water immediately before it is filled with the hydrochloric acid. Okay, that is a good question. That is that is one of the most uh, practical based questions. So the reason is, when you wash with water, when washed with water, some water, I'll just say, you can write it down if you want. When you wash with water, some water particles may remain in the beverage. And when hydrochloric acid is added after that, the water might change the concentration of the hydrochloric acid, resulting in an improper uh, titration result or incorrect titration results. Okay. Next one, suggest why universal indicator is not suitable for this experiment. Okay, universal indicator in the sense it's like you can think it as a pH paper. So the problem is it doesn't give a clear color change. The main thing is it doesn't give a clear color change. If you take pH, it has a different color for different instances. So you don't want to show color change for each instance. You need to change. You need to have a quick and instant color change at the equilibrium point, equivalent point. So we can write does not have a clear endpoint, or color change would not be as clear. Next question. A student investigates solution W and solid X. The solution W is green in color and contains Fe2 plus ions. Fe2 plus ion is in general it's a dark green precipitate when it's mixed with water. Describe how W can be shown to contain Fe2 ions. So as I said before, Fe2 is a dark green precipitate. So if you add something like some kind of a base, to the solution, the Fe2 plus ion will take it and form FeOH twice and forms a dark green precipitate. So you can say by adding a base such as ammonia or sodium hydroxide. Okay. Excess W is added to acidified potassium manganate. Describe the color change. Here they are not expecting you to write the color change of Fe2 plus ion into Fe3 plus ion. This is one of the most popular reaction. I'm not going to write the reaction now. The color changes from purple color. The solution of potassium permanganate changes from purple color to yellow color. Describe the observation made when few drops of aqueous ammonia, then an excess amount of aqueous ammonia is added to the mixture. Few drops added means red brown precipitate is formed, and when you add excess, no change can be observed. So you can say that it's insoluble in excess. So solid X is a shiny gray metal. The test the student does on X are shown in the figure 3.1, table 3.1. Some of the observations for this test are shown. Add the excess dilute acids to X in test tube. Okay, you can read this thing. I'll do it quickly. So solid disappears and becomes water. Okay, if it is dissolving, it can be uh, it can be one of magnesium or zinc. Those are the things that disappears completely, but we can't say for sure. Okay. How soon does gas can form in this experiment? Remember, when a metal reacts with an acid, and liberates a gas, it's mostly H2. Sometimes CO2 and N2 can also be possible, but we don't know, right? We have no clue. So if they're asking like this, it's definitely hydrogen. In a syllabus, mostly it's hydrogen. Uh, it's very rare they're talking about NO2, NO2, CO2. Remember, NO2, CO2 possibilities comes when it is something related with the carbonate or a concentrated nitric acids. Here it's dilute nitric acid, so there is no possibility. It is a gas component of nitrogen. Okay. The test is expose a burning splint to the gas. Observation, pop. So this is one of the famous experiment in the lesson. The observation for the test 1 are incomplete. State 1 other observation the student makes in uh, test 1. Okay, what is test 1? Test 1 add excess dilute acids to X in test tube. The gas produced is tested. Solid disappears, solution remains colorless and becomes warmer. Yeah, as that is a gas evolving, you can see bubbles. So the technical term for observing bubbles is okay. Next term. State the conclusion you make from test 2. From test 2. What is test 2? Adding nitric acid and then add aqueous silver nitrate to the solution from test 1. Solution remains colorless. You can say no halides present. This is a direct theory. No halides present. No halide ions present. State the conclusion you make in test 3. What is test 3? Adding dilute nitric acid, then add aqueous barium nitrate to the solution forms white precipitate. So when there's barium, you can and there's a term acid, it's definitely you can go for barium sulfate. So you can say sulfate ion. Sulfate, so 4 2 minus ion is present. Identify the acid used in test 1. So as there is a sulfate ion is there, we can say it's a H2SO4 or sulfuric acid. Suggest the identity of the metal. I told you before it could be magnesium or zinc. Okay, this is the last question. Baking soda is used to make bread rice. When baking soda is heated, it decomposes and carbon dioxide is released. Baking soda also decomposes gradually when it is stored. The longer the baking soda is stored, the lesser carbon dioxide it releases when it is heated. Plan an investigation to show which of the two different examples of baking soda has been stored for longer period. Okay, longer. Your plan should include the use of common laboratory apparatus and 2 samples of baking soda. No other chemicals should be used. Your plan includes apparatus, method of use, the measurement to take, the variables to control, and how to use the results to determine the sample store. Okay, I'll explain this question. This is a creative question. You have to think and do. They're saying like we have two samples of baking soda. The factors we need to consider is both should have same. I'll explain first. One is new, the other one is old. But we don't know which one is which. We need to find it out. So we need to measure the weight of both ones, and so the control factor is both should have same mass, and both should have same surface area. If this is powder, this is also powder. One can't be lump, and one can't be what do you call this, powder. Next thing is, when it comes to heating, both should be given with same temperature for same time. Here also it's the same thing. So these are the controls you have to use. As we are measuring the mass, its temperature and time and stuff, we can say that we are using stopwatch, thermometers, measuring scale and stuff. So first one, apparatus, stop, don't write stopwatch at first. Scale, Bunsen burner. We can also use heating plate, that's also fine. And we need to hold this thing in some places. So what is a suitable thing to hold it? Some might say it is watch glass. But remember, at the end of the experiment, we have to collect the CO2 gas released from it, and we have to measure. So the best thing is you can use a test tube, because in a test tube you can use a rubber cork on top and put a hole and connect this to a syringe or something like this, and the piston moves according to the volume of carbon dioxide collected. Okay, I hope you it's understandable. So you can write test tubes. Test tube is a good one. Or if you are going to use a conical flask, you can write a conical flask or whatever the flask you are going to use, and you have to somehow justify that it can be used to collect the gas. The best answer is test tube. And yeah, Bunsen burner, test tube, and temperature won't be an issue, because you can set the Bunsen burner to the appropriate flame, and it will give the appropriate heat, the fixed amount of heat for both things. So you don't have to write the thermometer separately. And we need something to hold the test tube on flame. So what is the name of that instrument? Yeah. Some students might ask, is it possible to use crucible? But crucible is not a good thing, because you can't collect the gas from it. It's waste of it is mostly porcelain or ceramic, so gases might escape from it. So it's not a good thing. Uh, so you can use some holder to hold the test tube. That's also fine. Fine. Next is method. Method I'm not going to write. I'll just say. Uh, Expose both of the baking soda to the Bunsen flame at equal temperature for equal period of time. Collect the gas evolved into a syringe or a gas jar using, if you're using a gas jar, you have to mention that you're using downward displacement of water as the technique. If it is a syringe, you don't have to mention that. Measurements to be taken. Mm, okay, if you have written thermometer, you have to write the measurement as the temperature. But I have not written thermometer, so you can write the measurement. Masses of each sample of what do you call this, baking soda. Volume of carbon dioxide obtained. And yeah, that's it. That's enough. Variables to be controlled. What are the variables to be controlled? Both baking soda should be in the same mass. Both should be heated to same temperature for same period of time, and both should have the same surface nature. Such as if it is a powder, both should be powder. If one is lump, the other one should be also a lump. But it is better to use powders because it will give the maximum result. But in this experiment, it doesn't matter. How to use the result to determine which sample has the storage stored for the longest longer. So the sample which gives the least amount of carbon dioxide is the one which is stored for the longer period of time. Okay, that's it for the paper. I hope you understood it. If you have any questions, leave it down in the comments. I'll reply to it as soon as possible.